All right, today we're going to look at exponential functions. What is an exponential function? So an exponential function with a base b is denoted by the f of x is equal to b. Is equal to b to the x. Where b and x are real numbers. So in these problems we will have a variable for a power. Notice a couple of things here in the definition. B has to be greater than 0, because obviously if you have 0 to a power, it's going to be 0. And B cannot equal 1, because 1 to any power is going to be 1. So that would be would be a constant. So we're going to just start by evaluating, plugging things in. 2 to the third is B. Easy there. Plugging this one in. 2 to the negative 3. Is 1 over 2 to the third, which is 1 over 8. And then f to the 1/2, evaluating that for 1/2, 2 to the 1/2 is the same thing as taking the square root of 2. And that's what I would want. Don't use your calculator. Give me the exact answer. For the next three, going with G, 2/3 to the 0 power. Anything to the 0 power except for 0 is 1. 2/3 to the negative 1, because it's negative, I need to flip it. And that's actually 3/2. This one we're going to change to 2 and 1/3. That's what I meant for it to be, because 2.3 you'd have to use a calculator. So this is actually G to the 7/3, which means that this would be 2/3 to the 7/3. If you recall what that means, it means that this is a cube root of 2/3 to the 7th power, which we could actually probably do that. We'll just leave it like that. For the h ones, the h of 1 plus 3 to the 0 would be 1 plus 1. H to the second, 1 plus 3 to the first, which is 1 plus 3, which is 4. And h to the 1/2 will be 1 plus 3 to the negative 0.5, the negative half, which would be 1 plus 1 over the square root of 3. Can't leave the square root in a denominator, so that would be 1 plus square root of 3 over 3. And so that's how we just do that. We plug in for x, what the x evaluated as, and do our output. What about looking at the graph? Here we have the graph of exponential growth. That's when b is greater than 1. The other one, which is exponential decay, that's when our value is a fraction less than 1. So no matter what, generally for our parents, our domain is negative infinity, positive infinity. That's how wide it is. We can see that it goes forever on both of those. Our range is only above the x-axis, so 0 to infinity. X-intercept, where does it touch the x-axis? It doesn't. In fact, that is a horizontal axis right there. So y is equal to 0. Our x-axis is a horizontal axis. And our y-intercept is always going to be at 0, 1 for our parent function. So those are that's the general information. So how do we graph? These are our steps to graphing. We label the y-intercept. So we always evaluate it at 0. We label 2 additional points. I like to use 1, so evaluate it at 1, and negative 1. Sometimes we have to do some other ones, just depending on, in general, what it's looking like. And then we connect with a smooth curve. So let's look at some examples. Pretty easy here to do. Start with f of 0. Plug the 0 in. That's 4 to the 0, which is 1. Which we said all the parents would have that. And that is a parent. It's the parent of all the 4 to the power of x functions. F of 1. Plug in a 1, we get 4 to the 1, which is 1. So 1 positive 1, which will be 4 to the negative 1, which is 1/4. There we go. And you can see domain is all real numbers, range is 0 to infinity, and then it has a horizontal axis at y equals 0. So number 2 is same function, just to a negative x. So if we think about what the reflection, that we had a negative with our function, that meant we were going to see a reflection. So let's see if that's true with this. So the f of 0 would be 4 to the 0, which is 1, so it goes to that same point. F of 1 is going to be 4 to the negative 1, which is 1/4. And then the f of a negative 1 is going to be 4 to the first, which is 4. So yes, it was definitely flipped around, still has that same aspect, but it is going up. Now let's look at our bases of fraction. According to what we wrote up here, looked at up here, for bases of fraction, we are going to be decreasing. So let's see if that's true. F of 0 is equal to 1/4 to the 0 power, which is 1. Next spot. F of 1 is going to equal 1/4 to the first power, which is 1/4. And the f of negative 1 is 1/4 to the negative 1, which is 4. It is just like the one we just did. So that being a negative x is also being a fraction. Kind of makes sense. Think back to what we know about negative exponents. All right, let's take a look at some transformations. So an easy way to graph these, if you recognize the parent or know, in general about the parent, is to just do it as a transformation. But we'll look at both ways. So we have our parent already graphed. We can see the f of 0 is 1, the f of 1 is 4, and the f of negative 1 is 1/4. Now, this next problem here has a -1 up with the function. If you remember, like being with the parentheses, that would be a horizontal shift. So that means that it's the parent or the x shifted, in this case, right, because minus needs to go right, and it's shifted 1. So we could just shift these points over 1, over 1, over, over 1, shift over 2. And there, that would be our line, our curve. You could also test those values if you wanted to. If you wanted to be short, just our three test values we use. If we plug in a 0, that's 4 to the negative 1, which is 1/4. What I have right there. F to the 1 will be 4 to the 0, which is 1. And then F. Now this is the case where I told you sometimes you pick a different point. I could do the negative 1. That would be 4 to the negative 2, which is 1/16, which looks like, it's obviously getting closer to the x-axis. But I really want to test this one. So the f of 2 is going to be 4 to the 2 minus 1, which is 1, which is 4. And that's exactly where we are. Now let's look at a vertical shift. How do I know it's a vertical shift? Well, plus or minus. But it's not in the parentheses right with that power with these ones, so it's not with the power. So I could just take the parent and say, hey, that shifted up 2, and go with this point and go up 2, 1, 2. Go with this point, go up 2, 1, 2. Go with this point and go up 2, 1, 2. And there we go. Now if you want to just double check, f of 0 would give you 2 plus 4 to the 0, which is f to the 1 will give you 2 plus 4, which is 6. See, that's the point we had. We get those 2 points. And then you could do x to the negative 1, which would be 2 plus 1/4, which is 2 and then 1/4, which is where that point is. Something here to note though, looking at my parent function, horizontal asymptote was the x-axis, y equals 0. For the second one, with our horizontal shift, we can still see it's the same thing. Horizontal axis, or horizontal asymptote, is our x-axis, which is y equals 0. But with the vertical, which makes sense, because if you're shifting the whole thing up or down, that asymptote is also going to change. So here it's right here. So y is equal to 2. Relates to that. Now let's take a look at one more. There's our parent function. F of 0 is 1. F of 1, in this case, is 2. And f of negative 1 is 1/2. And let's take a look at this transformation. So two things you should notice here. First thing I see, horizontal shift. Then I see a vertical shift. So I know it's going to go right to, down to, which I could do with the points. I could go right to, 1, 2, down to, 1, 2. Right to, 1, 2, down to, 1, 2. Right to, 1, 2, down to, 1, 2. There we go. But if I wanted to check, f of 0 is going to be 2 to the negative 2 minus 2, which is 1/4 minus 2. 1 3/4. I didn't actually do that one, so adding that about looks where I'm going through. F of 1, let's do the one that I actually moved. That's going to be 2 to the negative 1 minus 2, which is 1/2 minus 2, which is, oh, I should do a negative, negative 1/2. Yep, that's where I am, right there. F of 2 would be 2 to the 0 minus 2, 1 minus 2, which is a negative 1. That's right. And I could check f to the 3 if I wanted to. F to the 3 is equal to 2 to the first minus 2. That's 2 minus 2, which is 0. Work out. Now, of course, the difference here is where is our asymptote. Horizontal asymptote is a shift. It is negative 2. Y equals a negative 2. Do that. Now, you've heard of E. If you recall what E is, it's this function evaluated as the variable m is large. So as we plug in a larger number to that, we start to notice that the f of m converges to this number. So as m goes to infinity, our function goes to 2.71828. So for these, we would just plug it into the calculator. We have a calculator. E to the 1, 2.71828. That's what that's converging to. E to the 3 is, plug that into your calculator. I'm going to round it, 20.09. E to the 2.4, 11.023. And just plug it into your calculator. And this one, E to the negative 0.32, would be 1.37. Now, looking at the graph, you can see this is a exponential growth. If we wanted to check those points, e to the 0, or at 0, e to the 0 would be 1, so it has that point, see? And then we check at 1, e to the 1 is at 2.71828, right there. And then if we plug in a negative 1, we get 0. E to the negative 1, sorry, equals 0.368. Put it up there. 30 similar to our power pursuits of that. Now, what would this one be? Well, this should be a reflection. Let me change colors here. You can see it's a reflection because there was that negative up there, which means it would go the opposite way and be a decay, and then it's going up 1. So I could just pop this up 1, pop this up 1, oh, but it's on the opposite side because it's a reflection, and pop this up 1, but on the other side because it's a reflection. So this one is going to convert to low and low to further. That is going to have its horizontal asymptote for 1 equals 1. Now, could you plug in the values? Yes. E to the 0 plus 1 is 1 plus 1, which is 2, which is where I said. We check it at 1. E to the 1 plus 1, that's going to be 2.71828 plus 1, that's 3.71828. Oh, negative. This is a negative one, that would be lower. That's that. And then if we did 1, forgot that it had a negative there. E to the negative 1 plus 1.